Alright, with part 2 of our vectors for the day, first part we talked about just basic overall vocabulary, and then we're going to do a little more vocabulary and then actually just get into working some problems. With the different components of a vector, we can break vectors up into separate parts. A unit vector will be our first thing, and a unit vector is a vector with magnitude of 1. So a unit vector is a vector with magnitude of 1. It basically just has the direction component. It doesn't have really much length, it's just length 1. We will commonly use the letters I, vector I, and vector J to be representative for our unit vectors. And in the X direction we'll use the I, and in the Y direction we'll use the J. And so what that's going to look like on a graph, an I unit vector is going to be going in the X direction 1 unit. A J will be going in the Y direction 1 unit. We can use this with more sort of a complex vector. We can break down a vector V as components in each direction. So if we went 4I and 3J and we connect that, that would be where vector V would go. So we can break down that one vector into into a component of just the left and right direction and the up and down, and write it. That's almost like a rectangular form right there. Alright, so let's try a problem with changing vectors into vertical and horizontal components. Let's say we had something stuck and we start pulling on this object, and we're going to pull with 40 pounds of pressure at 60-degree angle. And we're going to try to break this into the two components. So I'm going to try to draw a sketch first just to get a picture of what we're dealing with. And so there I've made my 60-degree angle, and then the length would be 40 pounds. And I can try to find the I direction. Basically, remember I just said that was like my X component. If we think back to, this is really going like a polar, and so to find the I coordinate, that's almost like finding our X coordinate on our polar, and we can use that formula we used last chapter, R cosine theta. And so plugging in for J, we could do the same thing but use R sine theta. So to work for the I component, it would be 40 times, and then we got to figure out what cosine of 60 is. I'm going to reference my unit circle, and cosine 60 is a half. And then 40 times a half would be 20. Doing the same thing for our J component, we know that we do 40, and then looking off the unit circle, we can say sine at 60 is root 3 over 2. And then when I multiply that, I'm going to get 20 root 3. Therefore, and that's the symbol for therefore in math, therefore we can rewrite that vector as 20I plus 20 root 3J. Don't get confused with this I vector being the I imaginary unit. It's not the same. They're going to work so similar that sometimes I've seen people get confused with it. I don't want you to get confused with that. They're different things. Okay, so that is taking a number with direction and magnitude. We've translated it into the vertical and horizontal components. Alright, vectors, they are isomorphic to complex numbers. And isomorphic is a math word. Basically, when we break it down, iso means same, and morphic means form. And so everything we just learned with complex numbers, we can extend to vectors and use in the same respect. So vector V is going to be equal to R cis theta. So that last problem we just dealt with, we could really thought of that like 40 cis 60. And then that translate into basically the A plus BI form. That is our component form really. And so we're not almost learning anything really new with vectors. We're extending what we were dealing with complex numbers and applying that. Alright, so let's try an example with this of finding the resultant vector. And so this is going to be more than one force at a time basically. And I could give you there's several ways to work these problems, and I'm going to give you sort of the easiest way that will work in the long term. So let's say we'll start off with a smaller problem. We're just going to have two components. We'll say 100 pounds of force at 50 degrees, 300 pounds of force at 110 degrees. So this is like your truck got stuck, two different people's got total ropes. One person's pulling at a 50-degree angle with 100 pounds of pressure. The other person's a little stronger. They're pulling at a 110-degree angle with 300 pounds of force. So to sketch myself a picture of that, we have our truck stuck. There's rope 1 tied to it. Someone's pulling with 100 pounds of pressure. Then we'd go over, and that vector that I just sketched could also be attached down there at the origin. Since we're really doing vector addition, I've just slid it up to the end. And with that, that's the 300 pounds of force, and then that is actually at the 110 degrees in respect to like the origin. Now, where we want to find the red vector here, the component vector, or the solution. And all we have to do is add these together. Now, a neat thing that works with vectors is basically we're given polar form here, and we want to find out what the polar form of our red vector is. I can go back into the different components of the a plus bi form first and get the x coordinates. And if I add the two x's together, that will give me the total x for the red. If I add the two y's together, that'll give me the total component for the y. So that's exactly what I'm going to do. And just like with polars, to get x, y's, I'm going to have to use the r cosine theta and r sine theta. So I'm here representing, we've got 100 pounds at 50, we could represent as 100 cis 50, and the second one will be 300 cis 110. X is going to be equal to the x component of the first one, 100 cosine 50, and then if we add the x component of the other, 300 cosine 110, I'm going to type that in my calculator, and my red x component will be negative 38.32. My graph's a little off. And then going for the y components, it's going to look exactly similar. We're going to do 100 sine 50 to get the y component of the first, add the y component of the second, 300 sine 110, and that gets me 358.51 with some more decimals. Alright, so my ordered pair then, in rectangular form basically, would be the negative 38.3273, comma, 358.5122. And that is the red vector. But we're in rectangular form. They started out in polar form essentially, so we want to get back into that polar form. We're going to do the same methods we did with complex numbers. To find the r, we're going to set up Pythagorean theorem. So get Pythagorean set up, figured out we've got 360.56 for my r. Alright, to figure out theta, we're going to set up tangent inverse of the y over the x. And when I type that in, I've got a negative 83.9. Now, just like with the other ones, we want to stop here for just a minute and think. And that negative 83.9, I want to go look at that x value of my rectangular coordinate. Remember, when it's a negative, I've got to go and add 180. So I want to add 180 to this, and that gets me 96.1. And so that's going to be my angle. Alright, this was a quick overview. Watch this video as much as you need. You've got assignment today in class that's going to be just dealing with the same type of problems. So if you'll write this out, work them the same way. We can discuss them more tomorrow when we get back. But it's so close to how we did with complex numbers. It's not a lot new. So I think you guys are going to do a good job at this. And I'll see you tomorrow.